Hi, Scouts, and welcome. My name is Bill Raftery, and we are going to do Nova Down and Dirty. So let me start by talking a little bit here about what Down and Dirty is about. It's about geology. And we're going to take this opportunity to go through some materials here regarding how geology literally shapes our world, and also a little bit about the NOVA program through Cub Scouts. So to begin, we're going to have an introduction. We're going to go through some of the NOVA requirements. And by the end of this, you will hopefully have done the work and be able to earn your own NOVA patch. So, introduce myself. My name is Bill Raftery. I'm a den leader in PAC 1932 and the First Colony District STEM chair. So, what is the NOVA program? For those of you who have maybe never heard of it before, it was created several years ago as a program to excite and expand a sense of wonder in Scouts. It will seem similar to some of the work you do for your adventures, but it usually has a couple more components, and it's specifically science focused. So you'll see STEM awards relating to outer space and flying. You'll see, in this case, geology, archaeology, and all kinds of fun stuff like that. So to go through, each one of you should have in your packets a piece of paper that kind of lays out some of the information here and the requirements. You should also have some materials, including things like baking soda, vinegar, rocks, quartz, things of that nature. If you don't, that's okay. The nice part about this NOVA award is you can do all of it in your own home with household materials. So the first requirement to earn the NOVA award is a Scout must watch a TV show or read about the Earth, weather, geology, volcanoes, and oceanography. All of this is part of the bigger, broader package that we call geology. Okay, so can't do that here, but just think about some of the TV shows that are available. Some wonderful ones I would recommend is, if you have your cyber chip and are allowed to go online, I'd recommend a series called Crash Course. Crash Course has a number of videos related to geology, and they present it in a very fun fashion. So the next item is you need to explain. You have to do one of the options. I'm going to talk you through option A. Explain what geology means and collect samples of 3 minerals. Now, you have minerals in your box, as well as rocks. We're going to talk a little bit about what geology means. You could also do some of this stuff at your own home. As I said, quartz, very easy to find all around Virginia. So what is geology? Geo means earth and ology means study. So literally it is the study of the earth. It's a little bit different than astronomy, because astronomy kind of looks at the earth in the context of the whole solar system and the universe. Geology looks at the physical earth itself, all of its elements and components. And so that includes a little bit of things like the oceans. It includes soil. It includes the molten core of the earth. It includes everything that we think of when we think of dirt, basically, the earth itself. Historical geologists are a particular type. They look at the earth as how it's been formed. So when you think and you read and you go back and you find out that when the earth was originally formed, it was a big ball of hot gases and maybe some particles and dust and debris as it was spinning around the sun. And eventually it cooled and got cooler and cooler and cooler and cooler until finally, after millions of years, the earth basically cooled down to the point of being able to be solid. And then after millions and millions of years, and in this case, we figure somewhere in the ballpark of billions of years, it formed into what we call it today, into what we have today, okay? Physical geology is a little bit different. Physical geology looks at things like earthquakes, rocks, mountains, features of the earth. So if you have a physical geologist, they're going to talk to you about things like the different types of rock, okay? They're going to talk to you about how the glaciers carved things out. They're going to talk to you about how erosion, you think of the Grand Canyon. The Grand Canyon is a geological wonder because it was cut into the rock itself by a river over the course of millions of years. What's a mineral? Now, we've talked about rocks and minerals. They're not exactly the same thing. They're not quite interchangeable. A mineral is a naturally occurring and are typically either a single element or a combination of elements. So when we talk about minerals, we're talking about things that aren't just a combination of a whole bunch of things. Minerals, so a rock could be made up of a collection of minerals. But when we talk about things like gold or copper, those are elements or a combination of elements, okay? And what are some common ones that we see? Well, one of the ones is right in your own home. It's called halite or table salt. You'll also see a version of this if you ever have salt that you need to throw down in your driveway when it snows. But basically, as you can see, the dump truck, salt is naturally occurring. It's usually found in salt flats or salt beds where oceans basically dried out. And what they left behind was the salt that was in the water. And it's mined. It's mined just as you would mine coal, or you'd mine diamonds, or you'd mine just about anything. So it's a very common mineral. The second, and this is one you'll already have with you, is sodium bicarbonate, or also known as baking soda. Now, when you get it as a big, giant thing like that, it has a special name, a nacolite, okay? But that nacolite gets ground and sort of run through mills, and out comes baking soda, okay? Notice there's only really a couple elements here. There's sodium, okay, which is an element, and bicarbonate, which is basically, the focus here is on carbon, okay? So sodium bicarbonate. The next one is quartz, and it's silica. And silica is very common element here. This is a type of quartz. You'll see quartz all around here in Virginia. You practically have a hard time not finding quartz if you look down in the not necessarily in the gravel, but if you look around even just a little bit as you're walking around on your hikes, which I hope you're taking. Quartz is a very common mineral here in Virginia. There's all kinds of different types of quartz. There's rose quartz, smoky quartz, white quartz, all these other types of quartz. This is a picture of one in particular type. So minerals, very common, very easy to find, and they're a part of your life. I mean, think about the two we just noticed here. We talked about sodium bicarbonate, baking soda, that's your baking goods, and table salt, okay? And of course, quartz. The next question. So we're looking at requirement 3. Requirement 3 looks at volcanoes, okay? Requirement 3, option A, I should say. And how are volcanoes formed? What's the difference between lava and magma? And you either draw or build a volcano model, okay? So the first thing is, how is a volcano formed? Volcanoes typically are formed when two plates collide or subduct, okay? And that's what you see here. Subduction is a key geology term. Subduct, sub meaning it's going below. So you see the oceanic crust. So basically what happens is there's something called plate tectonics. And the way to think about plate tectonics is that the continents, our world, our Earth isn't just one big rock. It's actually a series of plates that kind of float on a sea of molten rock, okay? When those plates collide, you can see my fingers, when those plates collide, one of them tends to go down, okay? And it tends to go down. It's being subducted. But when that happens, you're shoving a lot of, think about it when you melt water, okay? If you put an ice cube down at the bottom of a bunch of hot water, guess what's gonna come up? The colder water is gonna come up. It's gonna melt and raise the water level. That's exactly what's happening with these volcanoes. When one goes down, up pops, I can do this with my fingers a little bit, up pops a volcano. Okay, do you kind of see that? And so you see that here, okay? So, sorry, I missed one. What's the difference between magma and lava? You'll hear the terms used interchangeably, but there's a difference. Magma is below the Earth's surface. It's hot, melted rock, okay? Once it hits the surface, it's called lava, okay? Lava, when it cools down enough, will actually form types of rocks. They're called lava stone or lava rocks. And in fact, you may have samples of it in your box for Cub Scout Camp Day. But they basically, it's that hot rock that just cools down. You want to see a version of this? If you've ever seen what happens to your marshmallows when you're at a campfire, if you let your marshmallow burn down a little bit, it gets kind of dark and brown. But if you let your marshmallow burn, there'd be a hard kind of rock thing. That's actually kind of carbon, and that's a lot of what you're seeing here with this magma. Okay, is the cooled down version of melted rock, or in the case of your campfire, the cooled down version of a melted marshmallow. Okay. So here's how a volcano builds land. Remember, all of that subduction is earth, a tectonic plate, going underneath. And so what pops up is lava. And when that lava cools, it creates territory. Now you can see here, all this fire and this dark black area is new land formation. That wasn't there before. It's pushing into the ocean. Okay, if you want to talk about places like Hawaii and various places throughout the world, they're basically upshoots of lava that have been cooled. Dirt eventually forms on them, grasses and all kinds of things. And so you have sort of a botanical base to it. But that's what a lava building land is. Now, of course, if it builds, it has the capacity to destroy. And here you see a picture of a volcano that actually exploded. Okay, now you see the trail here. You can kind of see a lava trail here, right? But in the process, it actually melted some of the rock around it. So it actually destroyed certain areas. It built up others, but it destroyed certain sections of land. Because remember, it's so hot that it's actually going to melt some of the surrounding rock that's already there. Okay, so volcanoes build land and they destroy land. Okay, what are the different types? Because not all of them are the same. Cinder volcano is what we think of kind of as the classic volcano. Okay, you got a hole at the top. It's kind of like a pyramid with a hole at the top. Very straightforward. A composite volcano looks very much like it, except it's parts of it kind of shoot out the sides. Okay, and so you see it's the lava that comes out the sides of the cone tends to be a little bit cooler. You see, you had fluid lava and then viscous lava, okay? Because it's not going straight up. It's kind of flowing up and then out and then down, okay? The third is a shield volcano, okay? That's typically where a volcano has already happened and over time it's been worn down by nature, but then the volcano kind of rears itself up again. And finally, you've got this sort of what's called a lava dome, okay? And a lava dome is where just that, it's kind of like a dome of lava appears and it's in a crater, okay, because of a prior eruption or a prior explosion, typically. And what happens after maybe a couple thousand or a couple million, 10,000 or maybe even a million years is the volcano re-erupts. And when it re-erupts, it re-erupts into that crater, okay? And that's called a lava dome, because when the lava cools, it forms a dome at the bottom of that crater, which eventually pops off. Okay? So what are the parts of a volcano? We're going to, for those of you who want to use the option of draw a volcano model with a cross section in order to fulfill the requirement for down and dirty, this is kind of what you're looking for. You're going to look for, there's a big section at the bottom called a magma chamber or magma reservoir. That's that big pot of hot rock at the bottom of a volcano that explodes up, or in the case of a composite, explodes up and then out, okay? The top of it is the throat, okay? You'll see there's the lava flow, ash clouds. When this billows out, remember, it's burning. It is burning hot. So you're going to have ash coming out, which is everything around it that's not heavy enough to kind of stay on the ground is going to go fluttering up, just like your campfire. You'll see side vents and some of these others, but the big things I want you to focus on are that magma chamber, the throat, the ash cloud, and then you have the vent, which is exactly where it comes out. Okay, it's that part, it's venting. Okay. Now, for those of you who want to experiment with building your own model volcano, we're gonna have that as an option. The first thing you need is your parents' permission. Okay. You're gonna need the baking soda and vinegar, which you should have. And if you don't, then you should be able to find these things around your house with your parents' permission. You need a tall cup or a bottle and safety goggles. I have to have my glasses on. and your parents' help, because this can get very messy very quickly. A couple other things I recommend is if you want to have fun with it, if you want to make it look like red magma, use red dye. However, please get your parents' permission. Red dye will stain. It'll stain you, it'll stain your carpet, it'll stain anything. So please be careful with that. And finally, a pen and a piece of paper. Why? Well, when you make your volcano, it might be easier afterwards if you build it on top of a piece of paper and the piece of paper's in a pan, then all you have to do is kind of clean up the pan and throw away the paper. It helps in terms of keeping things clean. Now, what can it look like? Well, here's an example. This is where you have the vinegar is already in, see that? And this person is dumping in the baking soda, right? And that's exactly what it looks like. There's that throat, right? And there's the vents. Now you don't see ash here, but you do see kind of like bubbles coming out. And that's exactly how kind of lava works. It's so hot and it's so interactive. You get those bubbles because air's kind of trying to come out. So that should be, and you notice they use a pan here. Again, I highly recommend if you're gonna do this, use a pan to try to keep everything collected, okay? So next question, what kind of education would I need in order to, in the future, to explore the Earth? There's a couple things. The first is you're gonna need certain academic degrees. Obviously geology. Geology is a pretty obvious one, but there's some not obvious ones. For example, physics. You know, when we talk about geophysics, we're talking about things related to how much pressure is being placed on the tectonic plates or on the continental plates. Where the you'll also see certain subcategories. So you have geology, you have oceanography, which is the study of the oceans, and obviously the oceans, at the bottom of the ocean, you've got Earth. And so sea quakes and the ramifications. Remember, most of our planet is water covered. And most of our planet is ocean. And so the study of geology and the study of oceanography are absolutely directly linked. What are some of the certifications? Well, you can get it, you can get degrees, you get certifications in particular areas. So for example, if you're looking at geospatial, which is the study of the spacing on Earth, cartography, which is basically mapping of the Earth, is sort of a subcategory and a sub-certification. And as I mentioned, some of the related sciences. So you have things like oceanography, you've got things like physics, and so on and so forth. What are the types of people other than geologists? I mentioned to you oceanography. There's also three others. Meteorology, which is weather, okay? The Earth affects the weather and vice versa. So when we talk about long term, when we talk about things like meteorology and climatology, we're talking about things, meteorology is kind of focused more on day-to-day weather. And so a hurricane may have an impact on flooding in your area, but it'll probably go away after a day, a month, or maybe a year. Climatology looks at the whole planet and the climate. And so there you get things, you're looking at things like the Ice Age. You know, you're looking at things like, why is it that here in Virginia, the climate is different in the western part of the state versus this part? Well, it's because of the mountains, okay? Obviously higher elevations. Finally, astronomy. Now, why does astronomy matter? For those of you who know, Chesapeake Bay, which is just due east of us, is actually a classic example of astronomy having an impact on geology. Chesapeake Bay was at least partially formed by a meteor strike. So when you look at portions of Chesapeake Bay, it almost looks like a ball or a bay. That's the bay shape, was in part because a meteor hit. When we talk about things like why did the dinosaurs disappear? That's an answer that's both botany and paleontology, but it's also geology and astronomy. A meteor hit, I believe somewhere close to Mexico, and as a result threw up so much dust that it blocked out the sun, changed the climate, and effectively killed off the dinosaurs. So all of these deal with how geology is more than just an examination of the Earth. It begins with that examination of the Earth, but it has related aspects to it that kind of overlap. And as I said, oceanography is one of the classics. So what do you need to do in order to finish this project? In order to earn your NOVA award, take that worksheet, which should be in your box, or if you can't find it, go to scouting.org, and which is the official Boy Scouts and Cub Scouts website, and look for Nova Award Down and Dirty, and you'll find a series of worksheets. Take the completed worksheet and the model or drawing, photos of the model or drawing. So if you built a model volcano, take a picture of it. If you drew, just keep that picture to your next den meeting and submit it to your den leader or Cub Master and ask them to sign off on your Nova Down and Dirty. If they have any questions, feel free to reach out to me, Bill Raftery. That's braftery@yahoo.com. That's braftery@yahoo.com. And thank you very much for taking this opportunity, giving me this opportunity to work with you on the Nova Down and Dirty.